Hello, today we're going to write linear equations. Let me just remind you of a couple of the linear equations we've been working with. For example, one type is direct variation, and that is an equation of the form y equals kx, where k is the constant of proportionality, the unit rate. We could also say that that's the rate of change or the slope. So we have direct variation equations. We also have equations in slope-intercept form. And that's the one we just worked with, y equals mx plus b. So the only difference between this equation and the direct variation equation is that we have a y-intercept that is not 0, 0. Another type of equation we're going to work with today is called the point-slope form. Let me get that down, point-slope form. So this is new. And this type of equation looks like this. Y minus y1 equals m parentheses x minus x1. It looks a little bit complicated, but depending on what information we're given, this form might be the most useful to use. This could be rewritten in y equals mx plus b format, but it is pretty helpful if you know the slope and happen to know a point on the line. So I'll go into this further. Of course, there are many other kinds of equations that are linear that we could write, but these are the three that we'll be focusing on today. So let's just take a look at some examples. Just get a feel for this. Let's go ahead and write an equation using slope and y-intercept. So, for example, let's say I give you, this is given, a slope for a particular line of negative 1/3 and a y-intercept of -9. And I say write an equation for this line. Well, if I'm given the slope and I'm given the y-intercept, I can easily substitute these values into the slope-intercept form. Y equals mx plus b. Why? Because I was given the slope m, which happens to be negative 1/3, and I was given the y-intercept of -9. And remember that the y-intercept represents the point 0, -9. So x equals 0 when y equals -9. And my general equation then can look like this. Negative 1/3 x plus -9, or you could write negative 1/3 x minus 9. And there you go, done. If we wanted to graph this line, we could start with that y-intercept of -9, graph that point, and then with this slope of negative 1/3, we could move down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, and so on and so forth. Let's go ahead and figure out how we can write an equation from a graph. So let's say we are writing an equation from a graph. And all of our graphs will be lines. Okay. Let's go ahead and look at some of the examples from page 50, your handout. And let's just start with number 7. Okay. This is a special case. We have a horizontal line, so you might be able to figure out the equation of this line just by looking to see where this horizontal line crosses the y-axis. It happens to cross at 0, 3. But I'm just going to go through some general steps that we can take that will work with any line. Step number 1, take 2 points off of the line. Step 2, find the y-intercept. Where does the line cross the y-axis? Which it will do in most cases. And then 3, calculate the slope given those 2 points and write your equation in the form y equals mx plus b. Because if you know the y-intercept and you know the slope, you can use this form of a linear equation. So for number 7, we have, what do we have? Let's pick any 2 points. I might as well use the y-intercept, why not? So I'm going to choose 0, 3, and I'm going to choose the point next to it, 1, 3. I have my 2 points. My y-intercept happens to be one of them. And to find the slope, if you are unsure of what the slope of every horizontal line happens to be, you can calculate it. Subtract your y values on top, your x values on bottom, rise over run. we get 0 over 1, or you may have gotten 0 over negative 1, depending on which point you labeled the first and which you labeled the second. Either way, these both give you a slope of 0. So when you write your equation, it will look something like this to start with. Y equals 0x plus 3. Now this is not simplified. What is 0 times x? That's 0. So essentially we are going to simplify this down to just y equals 3. Again, it's special, but we can use these steps, go through them, and come up with an equation to this line. Let's take a look at number 8. Okay. It happens to go through the origin 0, 0. So in your head, maybe you're thinking direct variation, which would be correct. But let's go ahead and find another point on this line. Let's say negative 1, comma 1. So I have 2 points on the line. My y-intercept is clearly the origin of 0, 0. And the slope, let's go ahead and calculate that. My y's go on top, so 0 minus 1 over 0 minus negative 1. And I will get negative 1 over 1, or just negative 1. So that is my slope. I can substitute it into my equation, y equals mx plus b, so y equals negative 1x plus 0. Again, this can be simplified. If you want to leave it y equals negative 1x for now, I will accept that, but to be completely simplified, we would just say y equals negative x. Let's take a look at number 9. This one's a little bit different because it's not a special case. It's not a horizontal or vertical line, and it doesn't represent direct variation because it does not go through the origin. So let's choose 2 points off of this line, 0, comma 1. I'm choosing points that are close to the origin because they're easy to calculate, but you can choose any 2 points you want on this line. Now this one's a little bit trickier. You want to make sure that you actually do figure out another point that lies on the line itself. So if I go over to 1 and I count up 1, 2, 3, the point 1, comma 3 happens to be on this line as well. The y-intercept is 0, comma 1. And my slope, when calculated, I do 3 minus 1 over 1 minus 0. That gives me 2 over 1, so that equals 2. And my equation will be y equals 2x plus the y-intercept of 1. To check to see if these are correct, feel free to take another point off of the line that you see graphed and put it into the equation. Do you get a true statement? If you do, then it means that your line is perfectly fine. Let's go ahead now and see when we might use point slope form and how that might be helpful. Okay, so let's go ahead and write an equation given 2 points. So before we were looking at the graph. Now let's just say I don't give you a graph, I just tell you these 2 points lie on the same line. Write their equation. There are a lot of different ways to do this, and one way is to use point slope form. So m represents the slope, and you have 1 point x1, y1 that happens to lie on the line. So for example, let's say I tell you that 3, 6 and negative 2, negative 9 lie on the same line. You could go ahead and graph it and go through the steps that we just went through, but that takes more time. So let's work a little bit more efficiently. The first thing you need to do is find the slope. We've been doing that a lot. So let's calculate the slope. Maybe I'll do negative 9 minus 6 all over negative 2 minus 3. So negative 9 plus negative 6 is negative 15. Negative 2 plus negative 3 is negative 5. A negative divided by a negative is a positive, so this will be 15/5 or 3 over 1. And I can simplify that to just 3. So I know my slope. Okay, now I'm going to use one of the points and plug it into this equation. The reason why I can't use y equals mx plus b at this moment in time is because I am not given the y-intercept. So you can't just take one of these other points, the 3, 6, or the -2 and -9, and put one of those numbers in for b. It doesn't work that way. If I gave you the y-intercept, you could do that. But without the y-intercept, you need to use this other format. So you can choose one of the points. I might choose 3, 6 just because I have two positive values. Positives are usually easier to work with. And so how does this equation work? Well, I'm going to substitute values in for y1, x1, and m. So y stays the same. What am I labeling my y1? 6. My slope is 3, and my x1 also happens to be 3. Now you could have substituted -2, -9 in as well. I just want to point that out, that this would be okay to do. You'd have y minus -9 equals your same slope of 3, and then x minus -2. This could be simplified to y plus 9 equals 3 parentheses x plus 2. In the end, I could simplify both versions and get the same exact equation, and I can show you that as well. I will say that it is fine for you to leave your equation in this format because this is an equation to that line. However, this can be simplified. Both can be simplified to get you to the form y equals mx plus b. Again, you don't have to do this, but you might want to if you have to graph the line, because this is a little bit tricky right now to work with. You could make a table, plug something in for x, and then do your calculations and solve for y. It would just be a little bit more time consuming. So what might this look like? Well, don't forget you need to distribute. What am I talking about? Well, here with a 3. So I'm going to write y plus -6 equals 3x plus 3 times -3. I distributed that 3 to the x and to the -3. I'm now going to simplify where I can. I'm going to multiply 3 times -3 to get -9. And now it would be really helpful to get y alone. So to move -6 to the other side of the equation, I can add 6. And that will give me y equals 3x plus -3. These equations are equivalent. These are the same. But this one might be a little bit easier to work with. I said it didn't matter which point you substituted in for x1, y1, and again I can prove it. We will still distribute, and we will get y plus 9 equals 3x plus 6. I will subtract 9 from each side so that y is alone, and I get y equals 3x plus -3. So it is the same. I just needed to point that out. The only other situation you might be given is if you have a table. So if you are given a table, you just need to use the same steps from above, the ones that we just worked with. And basically you just take any 2 points from the table to calculate the slope, and you take any point from the table to substitute in for x1, y1. So take 2 points and calculate the slope, and then take 1 point to put into y minus y1 equals m, x minus x1. Okay, we will do a lot of practice in class. I will see you next class. Thank you. Bye.